All right, so let's move on to section 10.4, which is hypothesis testing of matched or paired samples. So when hypothesis testing matched or paired samples, that should be these characteristics should be present. Number one, there should be simple random sampling used. Sample sizes are often small. Two measurements are drawn from the same pair of individuals or objects. So I would say two measurements are drawn from the same, I'm going to change that to individual or object. I think that will make a little bit more sense. Differences are calculated from the matched or paired samples. The differences form the sample that is used for the hypothesis test. Either the matched pairs have differences that come from a population that is normal, or the number of differences is sufficiently large so that distribution of the sample mean of differences is approximately normal. So we're often interested in comparing the means of two paired or dependent random variables. So here's a first example. Distances that a golfer can hit two brands of golf balls from a tee. Okay, so we have two brands of golf balls, and we want to know if the performance of one is better than the other. So in order to test whether, one golf ball performs better than another one, is each golf ball is going to be hit by the same golfer. Okay, so we have golfer number one, and golfer number one can hit golf ball from the first brand 192 yards, and that same golfer can hit the brand of the second golf ball 180 yards. And we've got a separate column here, which is going to be the measurement of brand one minus the measurement of brand two. So if we do 192 minus 180, we get 12. So this is a column of differences. This is what we're going to be doing a statistics test on, this column. Now the calculator, so we'll put this data in, but we'll use the calculator to do the subtraction and create this third column for us. All right, then a second golfer came along and was able to hit the ball from the first brand 195 yards. Then that same golfer was able to hit the golf ball from the second brand 185 yards. So you can see that the data in each of these two columns is dependent on the golfer. Okay. That's what we mean by we're often interested in comparing the means of two paired or dependent random variables. So each of these are considered dependent random variables because these are both dependent on the thing that they have in common, which in this case is the golfer. Now, another example would be to compare the pre-weight and the post-weight of a person on a 6-month diet and exercise regimen. So the pre-weight is the weight of a person before they started, and the post-weight is the weight of the person after the 6-month diet and exercise regimen. So you can see here for person number one, they weighed 120 pounds before the 6-month diet and exercise regimen, and then 118 pounds afterwards. And in this column, where we do the pre-weight minus the post-weight, we're going to have 120 minus 118, which is a difference of 2. Okay, and person number two, who was in this 6-month diet and exercise program, they weighed 205 pounds before and 198 pounds after, for a difference of positive 7. So these two, the first two people lost weight in the course of a 6-month diet and exercise regimen. And if we look at the third person, they weighed 182 pounds before and 185 pounds after. So that person actually gained 3 pounds, okay, shown by a -3. So in this calculated column here, we can have positive and negative values. Now, how you do this in your calculator, we've already seen something like it already. So with the Texas Instruments calculator, you just need to go into the list editor, put all of the values for your first dependent random variable in one list, and I've got it here in list 1. And then you put the values for your second dependent random variable in another list, in this case, list 2. Then you select list 3 at the top, and you program it to be list 1 minus list 2. And you can see these values of 2, 7, and -3 are what was calculated here on the calculator. Now, I'm only doing 3 rows of data, okay, just as a demonstration. You will likely have more than that, okay, and this list will be longer. So using your calculator for this purpose is much more time-saving than it is for you to calculate these one at a time by yourself. Right? Now, when it comes time to use a statistical one mean t-test, you can, enter in a list as your data into the t-test, or you could do one variable stats and get X bar and S and N. Personally, I think it's easier, to use this list of data when you put it into a t-test, and you'll see an example of that later. With the NumWorks calculator, there's, I think, a better way, and a way that isn't as good. So if you go into the Statistics app, I think that works best, because you can put the first list in. So for random variable number 1, you can put that into V1, N1, and then random variable number 2, you can put that in V2, N2, and then for the differences, you could put that in V3, N3. And it turns out that the calculator test is only looking for data in V1, N1, V2, N2, or V3, N3. So the only way that you can input data into a hypothesis test on the NumWorks calculator is to use the Statistics app. Now, if you happened to use the regression app instead, okay, remember in the regression app, instead of storing values as V1, N1, V2, N2, and so on, it uses X1, Y1, X2, Y2, X3, Y3. And unfortunately, if you put data into these columns, it's not an option when you go to use the hypothesis test. So instead, what you're going to have to do if you use the regression app is go into the Stats tab and record these values yourself. And then you'll input those values into this function separately. So that can pose some problems because, you might end up rounding these numbers. And when you round those numbers and you put them into your function, that can lead to errors in the overall calculation. Or you could, save these two variables, on your calculator. That one would probably be okay. And then you can use these variables on your calculator, and you could plug those in and get a really accurate answer. Okay, so on the NumWorks, there's kind of 2 ways to go about it. One way is easier than the other. And that's also true with the Texas Instruments. I think the easier way is just to refer to this list. So down here below, I've shown, the best way to do it is to use the Statistics app and put the random variable, the dependent random variable values in V1, leave the frequency alone, leave it as 1. And in V2, put the random variable values in this V2 column. And then go to V3. This is where you're going to have your list of differences. And if you click OK, you can put fill with formula. And typically I would put empty, but if you scroll down to the bottom, and the option should be for V1 plus V2. And all you need to do now is just change this positive, this plus, into a minus. So down here below, we've got V3 equals, change the plus to a minus, and then hit execute. And column V3 is now composed of your differences. And V3, it will be an input you can use for this one mean t-test. Right? So before we get into an example, this is the function that your calculator is using to calculate a test statistic from a student's t-distribution. So subjects are matched in pairs and a difference is calculated. The differences are the data. The population mean for the difference is tested using a student's t-test for a single population mean where we need degrees of freedom, which is equal to sample size minus 1. So, again, I'm just giving you this function, for completeness, but this is the equation that your calculator is using. Now, if you kind of forget how to use the calculator single mean t-test, I want to refer you to section 9.5, where we used both calculators in the scenario with one sample mean where the standard deviation was unknown. And so we used an inverse t function or an inverse student's t distribution function to convert an area into a critical value. And we used a t-test to calculate the test statistic and the p-value. And so we're going to reuse that procedure here with this hypothesis test of matched pairs. Okay, so this is a good place to start. We'll do an example. Let me know if you have any questions.